Hello everybody, my name is Arben Kalzici. I'm a certified instructor and content developer with the Wolfram U team here at Wolfram Research, and this is Data Visualization Quick Start. We'll start, as is traditional, with a bit of an overview. The first thing we're going to look at today are some basic features of visualization. So what that means is that we're going to take some example data that just looks like, 1, 2, 3, 4, 5, and we're going to see how we can change the style of some charts involving that data. We'll see how we could maybe color the bars of a bar chart, how we could add some labels, what to do if that data were to contain some metadata, how we could access and display that in our visualization, and then we'll see how to combine all these options to make a significantly more complex plot with just a little bit of code. After that, we're going to look at creating a more complex but still basic plot. And in this case, we'll be using not just one-dimensional numerical data like 1, 2, 3, 4, 5, but we'll be looking at some data about some countries from the real world. And this data will be multidimensional, so we'll see how to plot that as well. After we've kind of gotten the basics out of the way there, we'll look at adding some extra touches to this multidimensional visualization. We'll see, in this case, how to split the data up by continent and how to reconfigure it so that we can add nice legends. Now, I'm talking about the country data here, but this is, of course, totally accessible to whatever your data might be. It's very useful to be able to split up and legend your data, of course. After that, we're going to take note that some of these quantities about the countries are not static, right? They change in time. So we'll pick one of the quantities to look at from a historical lens and see how that quantity has changed over time. And once we've done that, we're going to write a function that allows us to generalize this analysis and look at the data over time for any given country. And finally, we're going to put all of this together and make a nice, complicated, split-up, legended chart that has custom tooltips that have historical data. So we're going to put it all together. Let's start with the basics. So let's just look at how the default bar chart looks if we plug in range 5, that is 1, 2, 3, 4, 5. There it is. It works kind of how you'd expect. 1, 2, 3, 4, 5. There are the bars. Ta-da. There's an option chart style, and we can set it to pink. I do want to note here that this arrow is got just by pressing dash greater than, and it will automatically pretty print to an arrow. So that's how you set options in Wolfram Language. And once we set the chart style to pink, what should we get? A bunch of pink bars. Pretty simple. Now, we're not limited to using one color for all the bars, of course. Say we have 5 bars, 5 numbers. We can make the chart style be any 5 colors, say red, blue, green, purple, and then just some custom RGB color, like this. And we could use color function rather than chart style to automatically color each bar by its height, by its value. And there you go. And we can see here by plotting some random integers that it's really plotting by the value and not by the position. So there you go. You can see that the lower this is, it's a more purple color, and the higher it is, the lighter blue you get. And if we run it again with some different random numbers, a lot of 8s there for random numbers, but that's fine. You see that the coloring does work as expected. Now, we can also use different edge forms. So we can combine the color function, in this case gray tones, a kind of monochromatic simple one, with a chart style. And what this will do is it'll give us darker bars for lower values and brighter bars for higher values. And the chart style here with the edge form is going to allow us to get dashed, thick, red edges, like you can see here. So you can customize the way the edges of your bars look. Now, as for labels, a chart with no labels is really not useful at all, even though you might see that quite often. What we'll do here is we'll add some labels. So we're going to have range 5, just like before, and then we're going to add labels, which are just the same 5 numbers. So our chart labels here are 1, 2, 3, 4, and 5, which we didn't have above, as you can see. Labels could be numbers or strings or really anything. So here I'm going to label them with the string names of the integers, 1, 2, 3, 4, 5. Or I could even use pictures of my cat, Michio. So if I run this, there he is, labeling the bars. Perfect. So really anything you like can go here. Could be math expressions, could be country flags, could be anything. And we'll generalize this a little bit soon. And rather than using labels, sometimes it's nice to have a legend, right? So let's again use the same data set, I'm making finger quotes, and we'll do a dark rainbow color function with automatic chart legends. And these chart legends, automatic has generated us a nice gradient bar legend here. And you can also make an explicit swatch legend if that's your thing. So we're going to have 5 numbers, we're going to color them particular colors, and then we're going to specify that the first thing should be labeled 1, and then this one should be labeled 2, and so on. And this is just to show that just like the labels, the legends can be arbitrary expressions. Now, sometimes your data might already have metadata associated with it. So instead of adding the data later, maybe you already have tooltipped data, for example. And now if I mouse over, it's a little small, my apologies for the high resolution display, but if you mouse over, you should see 1, 2, 3, just like is specified in the tooltip here. And just like with labels and legends, the tooltips can be pretty much anything. So here's an example where we're going to create a list of country populations, and they're each going to have their own flag as a tooltip. So now if I mouse over, well, we won't see it here because units have their own mouse over pop-ups, but we'll see it in the chart. So bar chart, and I just put this data directly in. It just looks like this, and it has built-in country flag tooltips. And now if I mouse over, we can see the different flags. And these are the populations, right? Populations, and then the tooltips are the flags. So bar chart does support units automatically, as you can see here. And we could use callouts rather than tooltips. There are many different types of metadata that you could have or use. Okay. All the options we've used so far can be combined. So what we're going to do here is, it might look a little scary if you're not familiar with Wolfram Language, but it's not too bad if you take the time to look at it. Pause if you need to, but don't worry about it if you don't get it. We're going to make a bar chart that displays the populations of Central American countries. They're going to have name labels, population-based coloring, flags displayed in the tooltips, and the total area belonging to that country will be added in callouts. And there you have it. And if we mouse over, you can see we have the flags. And there it is. So you can combine all these options to make a nice little visualization with, for what you're getting, comparatively little code. All right, let's take this country idea and kind of expand on it a little bit to make more complicated charts. So we have those 1D charts, but most of the time your data is not one-dimensional, so you'll want to be able to plot multidimensional data. For cases like that, charting functions like bubble chart can be useful. So what I'll do here is I'm going to grab a list of all the countries in the world, and I'm going to get some data where I extract the name of those countries, the literacy rate, life expectancy, population, and the continent on which those countries reside. So I've got those, and the thing is, I call this untrimmed data, a bit of anticipation here. So the reason for that is that we don't actually have all of that data for every country. For example, the United States minor outlying islands, we can see here that some of this data is missing. So what I'm going to do, and this is something that it's useful to learn how to do for your own data, of course, is I'm going to take that data and I'm going to delete any entry which is containing any missing data, so I just don't have to worry about it. And now, versus my untrimmed data, I have some data. And let's have a look at, say, 6 random choices from this data, see what it looks like, just to get a sense of the structure of the data. Okay, Suriname, literacy rate, life expectancy, population, and the continent. And so, that's how this data is structured here. So it's a nested list, and then each of the inside lists has this data like this. So if we want to plot only the numeric data, what we need are the second, third, and fourth options here, right? So the second, third, and fourth options, or not options, but elements of each sublist are the numeric parts. So we can go to the data, we can go to all of the entries, all the countries, and get each of their second, third, and fourth parts, like that. I use a semicolon there to suppress the output because it's a lot of data. So let's see how we plot that. We can use bubble chart to do that. The idea with bubble chart is that you give it kind of X and Y coordinates like you would in a standard, say, scatter plot or list plot if you're familiar with Wolfram Language. But you can represent a third dimension by giving each point a radial size. So let's just have a look at it, and I think it'll be pretty self-explanatory. So what we see here is just a bunch of data. It doesn't have any labels or anything. It just has the three numeric quantities. It was literacy rate, life expectancy, and population. So what that means is that on this axis, the horizontal axis, we have the literacy rate. On the vertical axis, we have the life expectancy. They kind of cover similar ranges, at least on the top end. And then the radial size of each thing, of each data point, corresponds to the population of the country. This commits the cardinal sin I mentioned. Like I said, it doesn't have any labels. But we learned how to add labels, right? So we can go ahead and do that with our bubble chart as well. We're going to use placed here to place those labels in a tooltip. Data all one just means we're going to all the data points and we're getting their first entry, which you might recall was the country name itself. So I've added some frame labels, plot label, and the actual tooltipped data here. So now we have this, and if I mouse over, again, it's a little small. My apologies for the display size. But if we mouse over, we get the names of the countries here. Monaco, Italy there, India, Nigeria, and so on. So that's how that works. Okay, now that we've got that kind of multi-dimensional chart out of the way, let's see what we can do to spruce it up a bit. We can add some extra touches. You might note that we had the continent data in each data point, but we didn't use it in the above visualization. So what we could maybe do is split the data up by continent and then color all the bubbles according to their respective continents. Random choice of data will just show us, again, a kind of random data point here. So if we just run it again or again, we always get some random country and then its statistics and its continent. So the last part is what tells us what the continent is. So if we use gather by on the data by its last continent, or by its last entry, we're going to gather the data into chunks based on their continents. And we can see that indeed the new list has 6 entries at the top level, one for each continent that has countries on it at least. And we can see that, say if we go to the first list, we can see that we get 3 countries in Asia. And indeed, if we take 3 random countries from each of the 6 continents, we get 3 from Asia, 3 from Europe, 3 from Africa, 3 from Oceania, 3 from North America, and 3 from South America, as you would expect. So now we have a nested list where at the top level we have continents, and then we go one level deeper and we have the countries and their numerical data points. So let's reconfigure this data for legending now. Because what we're going to want is we're going to be able to say, okay, blue is North America, or red is Oceania, or whatever. We want to be able to actually indicate what color means what continent. So let's get a list of all the continents. So we're just going to get all the continents and delete duplicates. So that gives us the 6 continents there. And let's go ahead and get the numeric data one more time. We're going to add a tooltip with the country name like we did before. So this is basically what we did on the previous slide, except now we're going to map this, instead of mapping it onto the top level, which is continents now, because it's data by continent, we're going to map it one level down at level 2. We're kind of counting down as you go down a tree. So we're going to get tooltips for each country with this. Let's go ahead and check this and make sure that it kind of did what we wanted. So let's get, let's say, 2 random data points from each continent. Make sure everything looks good. Okay, so there's the numeric data. Azerbaijan and Russia. Okay, so that's Asia. We have Belgium and Finland there, so that's Europe, and so on. If we go down, we have 2 data points for each country, and they do have the country names in the tooltips. So now we've got everything we need to put together a bubble chart with a nice legend and tooltips and everything. So let's run that. And so we have this here. It's a little cluttered. We'll take care of that. But you can see we have a nice set of legends that correspond to the colors here. And you can see that we got that by just using chart legends, go to the continents that we defined, and we had our numeric data by continent with tooltips. So the actual code here is quite simple once we have our data sorted. And it's worth noting here that this type of chart was popularized by one Hans Rosling, who showed animated versions of this, not necessarily these statistics, but, things like literacy rate, life expectancy, GDP, some measures of health, things like that. And he would show animated versions of it to visualize changes in these metrics over time. And of course, what you would hope to see is that over time, more and more countries have better metrics, so they move up to the and to the right. And then sometimes you might see things like vast sicknesses or war, and you might see countries kind of drop down and to the left for a bit, but then they hopefully recover and move up and to the right. All right, let's get into some further details now that we've seen how to break the chart up by continent. All those properties change in time, but let's just pick one to visualize changing through time. Let's have a look at the population changes over time. Let's just do an example with the United States here so we can kind of see how to do this, and then we'll generalize it to other countries. So what I'm going to do here is I'm going to get all the years, every 10 years from 1910 to 2020 in steps of 10. And then I'm going to also add on annual data from 2021 through 2028. So I do that, and the result is, well, I get a little year object. So Wolfram Language knows that this is a date, that it's a year. You'll see why that's important momentarily. And population. So we have a list that's just kind of a coordinate pair list of year and population that corresponds to that year in the US. And we can use date list plot to plot data that looks like this. I'll add some filling to make this look nice, and we'll add some plot markers so that we can actually see the individual data points, not just the lines that connect them. So here we are. So there's the population over time of the United States. Ignore the no labels. We're just testing right now. It's fine. It's fine. And, I'm not in the future. So as of the time of creation of this notebook, we've only played out fully the years through 2022. So those data points beyond that, that are kind of the last few data points here, are estimated. So it would be responsible to indicate the fact that those are estimated on the plot, right? So what I'm going to do is I'm going to take our population data that we defined, and I'm going to split it into two chunks. And how do I know when to split it? Well, once the first component, that is the year, is greater than 2022, I'm going to start splitting. So I'm just going to go through the list, and then once I find a year greater than 2022, I'm going to split it in half. Well, not in half, but into two pieces. You get my meaning. Then I use basically the same stuff. I add some labels, and I get this here. So you notice we automatically get a different color for our two, quote, separate, unquote, lists, and my plot legends will automatically correspond to those colors with the nice lines and data points automatically filled because those were the options that I used for the chart. So that's quite nice. That plot is quite nice, but again, we only looked at data for the United States. So what we should do now is we should generalize this process into some function that can take any given country as its input and produce a graph like that, like we just saw, as its output. So let's do that. This is right here. I'm basically doing the exact same thing I did on the last slide. If you compare the information, you'll find that the code is basically exactly the same. The only thing here is that instead of specifying the United States, I'm going to allow for a country name to be input as a string. And then we're going to look up that country, get its data, and we're going to make a plot. So this function does all that automatically. All it needs is a country name. So let's say date plot maker, Albania. There it is. We can look at the data for China. You can see there's a slow decline in the recent years there in Chinese population. And date plot makers say Ecuador. There we go. We can see that this is rising quite quickly. It's a little slower recently, but it's still rising quite quickly. Now that we have this function, we can use it to expand the bubble chart visualization that we had before. Let's put all this stuff together now. We made the bubble chart before, and it had tooltips, and it showed us the continent names and everything. So let's just have a look again at that so that we can kind of see what that looked like and what we're going to have to change to add the new tooltips with the cool date plots, with the populations changing over time. So here's what we had before, right? Here's how we defined numeric data by continent with tooltips, and then we made a bubble chart. And that was the code to make the bubble chart. once we had this defined. Okay. Now, with the new visualization function that we developed, all we have to do is we're going to do the exact same thing to make the data, except now instead of just putting the country name here, we're going to get the country name, which was the first element of each country data point, remember, and we're going to feed that into Date Plot Maker to make a plot for us, a date plot, no less. So we just run this, and once we've run that, we have our numeric data by continent with full tooltips. Whew. It's a mouthful, but that's the point. We can fit a lot of useful information onto a chart. So now we're going to take our chart, and all we're going to do is we're just going to replace the old data with the new data that has the full tooltips. So let's run this and see what happens. Okay, there we go. And I'll make this a little bit larger here, and we'll mouse over. And we'll see, say, India. So there we have our little chart that pops up. See this country here, Iran. We have that. We can click on here. Look at South Africa population over time. So now for basically all these countries, we do have historical population data for most all of them. There are a few that are missing, but as you can see here, we now get a lovely, interesting pop-up that shows what the population over time was for each country. And it even has labels. As you can see, this one says, Myanmar population, 1920 through 2028. It has its legends. It's got everything. It's all just in the little tooltip there. Now, due to the way that this data is laid out, it might be nice to make a few more tweaks. Let's make the graphic larger and relatively wider, which will also let us move the legend inside because there's some dead space up here. Okay, this looks a little bit nicer. And again, we still have all of our tooltips. We've got everything working. It's just we've changed the display a little bit. It's a fascinatingly smooth curve there on Japan's population, actually. And then we have, like I said, we have the legend inside here. Now, this data is a little bit clustered, as you can see. So it might be nice as a final touch to use some sort of scaling function to stretch it out to better fill the horizontal space. A traditional log scale compresses the right side or the upper side of the data, basically where the data is larger in whatever value you're interested in. But in this plot, that is where the data is clustered. So we don't want to compress that. We want to stretch that out. So we should use the inverse scaling of log. So here I've added a scaling function that's going to scale with an exponential scaling function instead of a log function. And so now, as we can see here, we have this lovely chart. And again, we have our tooltips. And we can check out the information for all of these different countries just by mousing over them. As I hope we have demonstrated, with just a little bit of code that you build up step by step, you can build really rich, interactive visualizations. And it doesn't need to necessarily be a graphics object that pops up in a tooltip. You can have all sorts of things. Like maybe you have audio samples from the languages spoken in each of these countries, or the dominant languages in each countries. You could even make it so that if a user were to click on one of these countries, they could hear a little sample of what the language sounds like. It doesn't have to be a flag or a graph or anything else. You can really do whatever you like here. You could have an image of some sort of holiday or celebration. You have a lot of different options here, and the primary limit is your imagination.